Hello and a very good morning, good afternoon and good evening everyone. I would like to welcome you to my presentation session, which revolves around a new discourse that is being increasingly spoken by policymakers, education organizations, educators and researchers alike. Also a developing area of discourse that has been rushed and expedited by the ongoing pandemic COVID-19. This discourse that I speak of is the digital transformation of education. Before I present my views, recommendations, and research findings on preparing for the digital transformation of education, I would like to introduce myself and the work that I do in the education industry. My name is Shai Omar Ali, and I am from Brunei Darussalam. You can find more details about me via my LinkedIn profile and my websites as shown here. I consider myself as an educational technologist, and whenever I wear my educational technologist hat, I will be involved in the evaluation, decision-making, and endorsement of digital learning ecosystems, digital learning content, pedagogical approaches, and teacher training. Other than the educational technologist hat, I am also a full-stack developer, which means a technologist that invents, develops, manages, and understands back-end coding, software application and games development, databasing and data analytics, digital functions, and front-end user interfaces and aesthetics. In other words, a full stack. Whenever I wear my full stack developer hat, I will be creating scripts and configuring logics and machine learning algorithms to create bespoke learning systems. And by wearing both hats at the same time, I am able to comprehend granular and complex design and development of systems, platforms, and applications. From designing the front-end user interface to be ludic, to be user-friendly, to be willingly embraced by our end users, to designing the system's back-end coding architecture, where I tend to prioritize on architecture that requires less need for technical experts, that optimizes long-term sustainability of the system, and to overcome digital obsolescence, and to encourage interoperability with other future technologies. If you would like to know more about what I do, you can link me up on LinkedIn. In a nutshell, I do a lot of research and development on emerging and new learning technologies such as smart devices, extended reality, cloud computing, AI-based systems, and digital games-based learning. These are just a few examples, of course. My presentation here explores the digital transformation of education, and in response to it, my recommendation for a framework that may guide organizations on what components of transformation are to be considered and the resources or features that are prerequisites to achieving them. Now, as a digital transformist myself for the education sector, I am involved in both the transformation of education management and the transformation of teaching and learning. The education management side involves matters concerning policies, decision-making, legal, human resource, and the financial management aspects of integrating new technologies. Technologies that associate with education management include big data analytics, personal data protection, return of investment, and research on the state-of-the-art that result in white papers and blue papers. In educational research, these fundamental components are often overlooked as they are fairly distant responsibilities for teachers in education, but not so for the organization, especially the education organization. In contrast, on the teaching and learning side, which is of course areas where teachers and educators are more interested and more invested in, transformation encompasses the learning management systems, the individual applications and apps, and of course the curriculum content. Matters that are more extensively covered in educational research. Given the two sides of digital transformation in education, my presentation here focuses on the transformation of teaching and learning, as with preceding research in the area, while also at the same time complementing my presentation with considerations of education management, because at the end of the day, the constituents of education management will likely influence the success rate of creating a digital learning ecosystem. In other words, we may have ideas on what makes a successful digital learning ecosystem, but the external variables and factors to implementing them, particularly when it is a full-scale implementation, are dictated by the businesses of education management. So, if we refer to the title of my presentation revolves on the creation of a digital transformation framework that considers both the aspects of educational management and the aspects of teaching and learning. In other words, a framework that guides whoever has been selected by the education organization to lead the digital transformation. Alright, let's now briefly look into the digital transformation of education. The digital transformation of education is nothing new. It's just that we've never coined it as digital transformation before. The body of literature that refers to the integration of digital technology and internet technology into teaching and learning, into schools and into lessons, oftentimes refer to it as e-learning, computer-assisted learning, and technology-assisted learning, or some phrase along those lines. For many years, because we have put focus on assisting our teachers and students to develop digital competency and inculcate the use of technologies, to then expect them to improve learning performance and learning experience, various experts have developed fascinating models to guide teachers and educators on the components that make a functional digital learning environment or learning system. We emphasize on learning platforms and processes that are interactive, authentic, conducive, attractive. Simply, we want to further enhance the learning dynamics that already have proven success in the traditional classroom settings, such as group work, problem-based learning, student-centered learning, and so forth. As examples, we already had Mishra and Kohler's TPAC model since 2006. We have Ruben Pentadura's SAMR model since 2010, which addresses transformative applications of information technology into education. We had several educational technology acceptance models, or TAMs, dating back to 2002, with the study of TAM in evaluating the efficacy of internet-based education systems, for example. And during my time as faculty in the United Kingdom, we embraced Gillies-Salmon's 5-step model. Before the turn of the 21st century, Dr. Gillies-Salmon was already researching on online technology in regard to online learning environments, moderation of learning, computer-mediated communications. So yes, the various experts that I've mentioned, and many others, still many others, have made great strides in preparing practitioners, whether it be teachers or policymakers, on what makes digital technology effective in teaching and learning. These models of enhancing learning dynamics tend to have a top level. For the TPAC, the central model, TPAC, is its top level or endgame. For the SAMR model, the redefinition stage is the top level, but in order to reach it, the system has to fulfill the stages of substitution, augmentation, and modification. The same can be said for Salmon's 5-step model. The top level is the 5th step, or the development step, and to arrive to that stage entails the fulfillment of the previous 4 steps in that model. The framework that I am thus proposing in this session takes a different viewpoint from the models I have previously mentioned, yet at the same time recognizing that they are still very useful and still very relevant today. Based on the review of the literature and through a few studies that I've conducted prior, I have thus developed a proposed framework that I refer to as Revamp, R-E-V-A-M-P. Its 6 aspects represent solutions that are realistic, engaging, virtual or virtual ready, adaptive, multimodal, and personalizable. The Revamp model has no top-tier level. It is what I define as a flat holacracy of 6 aspects of digital transformation that is all or nothing. There is no combination of RV or VAMP or RVM. Instead, the Revamp model draws from agility and scalability of each of its 6 aspects, depending on the developing trends of learning technologies in the foreseeable and perhaps distant future. The 6 aspects are intended to be sensitive to the contextual situations in which it serves as a framework for implementing digital technologies, because we recognize that different organizations or countries have different resources at their disposal. It provides the policy and decision-making stakeholders, and at the same time, the school and educated stakeholders, a shared clarity, a shared understanding, and a shared vision to comprehend a large-scale digital transformation. The main intention of the Revamped Framework is predominantly engaging the large-scale deployment of a singular learning ecosystem that is made up of interoperating and interconnecting and future-ready components. In other words, digital singularity. Revamp is a digital transformation framework for education to arrive to long-term, sustainable, and scalable solutions. Before I elaborate on the Revamp Framework, it is useful for us to recognize that digital transformation is a relatively new concept for educational research. We are aware that even with the World Wide Web in 1996 and Web 2.0 a few years after, the idea of education being significantly transformed by digital technology has been under research. It wasn't until the year 2008 that a journal article on digital transformation in education or for education was first published. And 2 years after, in 2010, the phrase digital transformation in education was used by then U.S. Secretary of Education Arne Duncan in his address during the State Educational Technology Directors Association Education Forum. But other than these two recorded references, the concept of digital transformation in education was hardly ever mentioned, in comparison to, for example, e-learning, online learning, technology-enhanced learning, or computer-assisted learning. These were the terms that resonated more because the idea of education and technology becoming an inseparable singularity was not a research priority at that time. Fast forward to 2021, the digital technologies that have been introduced into education are giving advantage and privilege to those who do have access. Less effort is required, for example, to find a non-indexed key phrase in a collection of digitalized books. These new gadgets and technologies boom available to the general public catalyze an unprecedented shift, a transformation towards digitalization. Some countries are more advanced than others, but ultimately we are all headed the same direction, the same outcome. And around the same time, talks of the Fourth Industrial Revolution further cemented the disruptive role of new technologies on our future. So we are indeed a few years on the apex of something absolutely big and altering to our education system. Not surprisingly, 2017 was the year when the topic of digital transformation in education finally became one of education sector's main discussions. Whether the Industry 4.0 declaration made in 2016 instigated it, or whether we as our respective societies are being instinctively awakened by our own observations of how more dependent we are on technology, the idea of transformation finally trickled into educational research. In 2016, less than 10 published research papers were dedicated to the topic. In 2017, we had 39 papers on digital transformation in education. In 2018, 47 papers. In 2019, 84 papers. Last year, more than 120 papers. So yes, we are now more aware that education and technology will likely become an inseparable singularity. We are now fully aware of this. But awareness is just one matter. How about preparedness? Preparedness is a whole different proposition, and one that I believe will benefit from a framework for both policymakers and educators to work together towards seamless transformation. Now that we have ascertained that the imminent role of digital transformation on education, the remainder of my presentation will now shift its focus onto the Revamped Framework itself, which is a framework of transforming technology-enhanced education to cater for learners' dispositions. For several years, I have researched and presented findings on the theory of learners having different sets of learning dispositions. These disposition sets are dynamic and can either be fleeting from one set to another within days, or remain stagnant and committed to a set of dispositions for years. Changes in these disposition sets are caused by external influential factors. For my previous research, I adapted the work of Pierre Bourdieu on the theory that individuals have different dispositions that are influenced by social, economic, cultural, intellectual, and technological factors, combined with exposure to different environments or fields. This Bourdieusian theory is indeed complex, and one that I will not elaborate in this presentation. But if you want to know more about my interpretation and adaptation of Bourdieu's theory, they can be found in my previous publications. Now, let's get back to the Revamped Framework. The Revamped Framework is a guide to implementing a singular learning ecosystem as an all-encompassing solution to cater for learners having different sets of dispositions, while at the same time a learning ecosystem that is future-ready. So let's now unravel the Revamped Framework. We begin with aspect 1, realistic. From the educator perspective, we are oftentimes fascinated by the idealistic features of emerging technologies. Certainly, the affordances offered by gesture interfaces, algorithm-based learner diagnosis, and augmented reality interactions are strong reasons for deploying them in lessons, because they are certainly impressive in the eyes of teachers and students. From the policymaker perspective, however, the reality of the situation is that there exist limitations to how far we want or how far we can realize idealistic solutions. The first limitation is resources. And resources can be further broken down into financial resources, human resources, time resource, and infrastructural resources. On financial resources, obviously we can agree that most emerging technologies are costly. The cost increases based on what the technology offers. For example, a Google Cardboard kit may cost less when compared to an HTC Vive Pro headset. But the reality is that an HTC Vive Pro headset offers far more features and functionalities than a Google Cardboard would, relative to the price points, of course. On human resources, superior emerging technologies tend to have more complex hardware, firmware, and code bases. In turn, these complexities require considerable human resource as technical support. And then we have to account for making different technologies work together in singularity with the ability to interconnect and interoperate with technologies such as API, SCORM, LTIs, and single sign-on. And then we also want to consider the end of life of these technologies. We would want our human resource to be a few steps ahead in terms of planning, migration, development, and implementation of replacement technologies, or even better, the in-house development of learning technologies. On time resources, when we decide on a learning technology, we also decide on how much time we are willing to invest in maintaining the operation of those technologies, and how much time in training the human resources required in maintaining them. This brings us to our second limitation in terms of being realistic. The second limitation is access. The concerns on inequity and inequality are very relevant, and many reports and literature have supported that digital technologies, when not implemented properly, exacerbates inequity and inequality. Bridging the digital gap and the digital dissonance that emerging technologies bring should be considered as a main part of the Revamp framework. Limited access can be caused by not having the resources mentioned earlier, but another that an organization has less control of is limited access based on end users' access and ownership of required technologies. For example, high-definition videos may be a more engaging, immersive experience, but does the user demographic all have access to devices that accommodate high definition? Does the user demographic have secure economic resource to sustain the high bandwidths needed? And would we want to demand from users to equip themselves with technologies that they cannot afford? These are questions that the framework will remind us to take into consideration. The third limitation is return of investment. Education organizations, particularly those that operate under non-profitable or social responsibility modus operandi, will have the best interests of the students in mind. However, any organization that wants to remain systematically operational would still want to be run like a business. Implementing technologies require budgeting and financial commitments, and for organizations, they regard the cost-benefit of implementing or procuring or spending human resource to develop these technologies in terms of return of investment. Usually, the return of investment is not in terms of monetary profit, but rather in terms of having students experiencing quality education, which in turn produces graduates who have diverse and future-ready skill sets, which in turn contributes back to the education system with new knowledge and new innovations. There is honestly a lot of accounting and balance sheets involved in digital transformation, but the debits and credits are not cash. In fact, instead, they are the resources spent over learners catered for. An organization would want the total sum of learners catered for to be exponentially higher than the resources spent. The Revamp framework will remind us to take into consideration criteria for selecting technologies that have higher returns. Having said all the limitations that are relevant to arriving to realistic solutions, a scoping review of the literature from scholarly databases supports the above theory. There is a dearth in research on the significance of maintaining their realistic educational technology implementation. Even when referring to the models of what makes successful technology-enhanced learning, the matter of realistic solutions are often overlooked. Research on the literature only unearthed 7 publications on realistic implementation, which is why the final 5 minutes of this video will share of the research study that complements this presentation, whereby the study measured what makes a realistic selection of technologies to cater for learners' disposition. Aspect 2 is engaging. In most part, I am referring to engaging as an adjective of the learning system rather than engage as in the verb. This differentiation is because in the literature, the verb engage has been overly used as a synonym to the word use, when in fact engaging as an adjective means more than to use. The word engaging defines productive interaction, defines that the learner is engrossed, is absorbed in the interaction, defines that it activates the learner's cognition, whether it be higher order thinking, metacognition, experiential learning, problem-based solving, inquiry-based, discovery learning, authentic learning, action learning, human-computer interaction, and any combinations of these engagements. Research a scoping search of the literature found 20 articles dedicated to engaging learning systems. These comprise of emerging interactions such as gesture-based interactions, gamification, digital storytelling, and learning by play. A measure of engagement is when the type of content piques the interest and curiosity of students. And measuring this by observation can be misleading. Moreover, activities where students passively sit or watch or listen can be engaging, but is the engagement productive? Students today have developed different and diverse patterns of attention span, multitasking, and memory retention, and it is thus in our best interest to figure out if the technologies we implement indeed align to these patterns. Again, the final 5 minutes of this video will share of the research study that complements this presentation, whereby the study identified what can be indicators of productive engagement based on learners' dispositions. Aspect 3 is virtual or virtual ready. The virtualization of learning is subjective to what is considered virtual. A virtual learning environment, for example, is regarded as virtual presence even when that presence is reduced to text-based representations such as posts in discussion forums and text comments on work exercises. On the other end of the spectrum is virtual presence in the form of avatars in virtual worlds such as Second Life, Altspace VR, VR Chat, Facebook Horizon, and other similar platforms. In between the two extremes, we have virtual labs where hands-on virtual practicals can be simulated, and virtual tours where students acquire a virtual first-person point of view. Webinars and teleconferences are often associated with virtual learning or virtual classroom. But considering that users represent their true form in online face-to-face communication, webinars are no more virtual than the depiction of people on television. For digital presence and experience to be virtual, the user has to be digitally represented as a virtual twin. Likewise, the landscape has to be digitally represented as a virtual twin. On 1st March 2021, the ECMWF announced a project called Destination Earth, which is a replica of our planet Earth. Imagine that, having a virtual presence in an actual living but digital world. Virtual reality technology has been an exciting prospect that is commonly portrayed on television and movies. Star Wars and Star Trek and Tron, to name just a few from thousands of movies that depict virtual reality. It is thus not surprising that a scoping review of the literature on virtual reality itself found more than 900 papers. More than 100 of these were on virtual reality and education, and more than 300 of these on virtual learning environments. Aspect 4 is adaptive. A scoping search of the literature found more than 180 papers on adaptive learning, whether it involves technology or no technology. Of the 180, 32 papers associated adaptive learning with education technologies. Of the 180, 51 papers associated adaptive learning with technology-enhanced learning. And of the 180, 25 papers associated adaptive learning with digital education. In the traditional classroom setting, an observant teacher constantly assesses each learner's satisfaction and learning effectiveness through formative input, performance scores, and the learning behavior. This approach is called differentiated instruction, whereby it involves a teacher attending to the learning needs of a particular student or small groups of students, rather than teaching a class as though all individuals in it were basically alike. An alternative to teacher-based differentiation is having a digital learning system that adapts to the preferences and abilities of the learners. An adaptive learning system is quicker in formatively assessing learners, and the repetitive matching of similar learner types with learner processes and learning processes results in a profiling database that can be reused and referred for future learner cohorts. Gorbani on Montazor in 2015 has demonstrated through their automatic learner's personality identifying system prototype that adaptive systems are more systematic in the assessment of a learner's current learning need. The experimental ALPIS technology uses an intricate fuzzy inference algorithm that formulates profiles based on learners' patterns of engagement with the system. The substitution of the teacher with digital technology, however, is not the easiest of tasks, for the technologies that are comparable to teacher presence are either based on complex algorithms that require technical expertise, or the still developing field of artificial intelligence to replicate the expected humanistic sensitivity when teachers subjectively and holistically assess their learners' needs. These challenges, however, should not thwart the option of adaptive learning management systems, as according to Bain and Ross in 2016, The technology of intelligent systems is a new frontier in teaching and one that should be embraced. An adaptive learning system is expected to be an automated technology that tailors the learning based on its impression of the learner. The realization of adaptive learning technology has been enhanced with the advent of artificial intelligence, business intelligence, and data analytics. Aspect 5. Multimodal or multimodality. I remember that during one literature review that I conducted on multimodality in 2017, there were less than 5 papers dedicated to the term multimodality. For this presentation, I revisited my scoping review and found that between 2017 and 2020, 17 other papers on multimodality has been recently published. Altogether, we have 22 pieces of literature on multimodality and digital learning. From the 22, 6 pieces of literature were specific to technology-enhanced learning and 1 was specific to educational technology. The literature further revealed that the multimodality of a learning system is represented through several forms. Firstly, multimodality can refer to content. There is the multimodality of how content is delivered and in what format it is being offered. Studies on multimodal online notes included the use of different multimedia, in particular verbal and non-verbal forms, and the multiple formats of learning via text, video, audio, images, and interactive elements. Secondly, multimodality can refer to the learning technology. This exists in the form of the various technologies that are used to interact with learners and teachers. Studies include the use of different narrative approaches in gamified learning environments, the use of several communicative features such as chat rooms, forums, audio, video conferencing to interact, the combining of audio, text, and graphics, webcasting and online text chats, and the likely discipline-specific use of gestures, speech, facial expressions, and graphical inputs. Thirdly, there is the multimodality in instruction and pedagogy. Several studies include having alternative instructions to reach a shared outcome or an objective, and the human-computer interaction based on multimodal instruction delivered by a robot. This form of multimodality is the least researched, and it may be due in large part to reliance in algorithms or AI to deliver tailored instructions, an area that is more associated with adaptive learning systems. The purpose of multimodal solutions is therefore to provide an array of alternatives that can be selected by the learners. Drawing from Hampel's work in 2002 on multimodality, Mahfouz and Imade conceptualized that in multimodal learning environments, learners exert more control over their learning situation, and the multimodal synchronous interactions allow learners to combine text chat, audio chat, and even graphics, thus working collectively at a distance in a multimodal and multidimensional learning environment. Aspect 6. Personalizability. A scoping review of the literature found 20 papers on personalizable digital learning, 11 papers on personalizable technology-enhanced learning, and 6 papers on personalized educational technology. Personalized learning environments is a relatively new concept that was first mentioned in 2006 in conferences on learning technologies. Van Hermelen in 2006 defines a personalized learning environment as a single-user e-learning system that provides access to a variety of learning resources, and that may provide access to learners and teachers who use other personalized learning environments and/or virtual learning environments. The main difference between this system and pure virtual learning environments is that the affordances, artifacts, features, functions, and tools involved are selected and structured and handpicked together by the learner to create his or her own system. The use of social software is prevalent in learners for social and entertainment purposes, which is why the idea of personalized learning environments and personalization has been an attractive proposition. Costello and Shaw shared several examples on what social software can offer learners through personalization. For example, face-to-face interaction using Skype, Twitter to share and communicate questions with other students on the course or globally, YouTube and SlideShare for self-regulated learning, Facebook to communicate discussions and engage within collaborative development challenges. The benefits of each type of social software on learning have been comprehensively investigated in recent literature, including Twitter, YouTube, Facebook, among many others. So to summarize, those are the 6 aspects that make up the Revamped Framework. Before concluding my presentation here, I would like to